So I've been meaning to talk about this containers and virtual machine stuff a little bit more because it sort of exemplifies some of the problems that we have, in broader society with meaning crisis and intimacy crisis, etc. If you want intimacy and meaning crisis stuff, navigating patterns is the place to go. That's where I talk about that. But still working through, say, all the manifestations that happened in the computer industry while I was there. Um, to some extent, thank goodness I'm not hanging out in that world anymore. Although, if you've got a nice high paying job, I'm on the market. Uh, I saw a video by Dave's Garage. I guess that he's on the autism spectrum or something, which whatever. And he talks about his time at Microsoft and things like that. And he went over, a one-on-one comparison of virtual machines and containers. And it was good. Like he didn't say anything particularly wrong. I mean, he left some stuff out, in my opinion, and but the problem is that perspective matters. And when you look at these things from a perspective of a single developer, the answers that you get are very different from the answers you would get if you look at it at the scale. A video on navigating patterns about scaling problems at the scale of a team, like more than one developer, right? And again, I've talked about this before. I don't know how clear I am on these things. You guys don't comment on these videos very much, which is fine. But if you can see it in your heart to tell me what's not clear, um, you've traded off developer skill, right, and speed of release for a huge overhead in DevOps, right? Some of that's just due to moving to cloud, but actually most of it's not. Most of it's due to developers don't know how to make things secure, and when you give them the run of things, they will just build things as quick as they can, and security gets in the way of that for sure. Security gets in the way of all kinds of things, slows down the development process tremendously, right? So, and you can't actually build insecurity into the software because most security breaches are not software problems. They're configuration errors. They're setup problems with network ports and services and how things are wired. And developers never do that work because they can't, because they don't know it, right? And it actually takes a completely different set of skills that have nothing to do with programming at all, right? Systems engineering work is a different beast. Is it harder or easier than programming? Who cares? Like, it's probably harder now because we've made programming ridiculously easy, or seemingly easy. But it doesn't matter, and you can't test for it because you have to put everything together first, do the integration work, and actually run it with all the parts correctly plumbed in an environment, and you have to have an external test set. And almost no one does that anymore for whatever freaking reason. But this problem of scaling is real. Like, what is faster for a single developer is not faster in a group ever, ever, ever. You can't say making 10 developers faster means our software will get out quicker. If the 10 developers have to cooperate, it will make everything slower, and it will destroy the quality completely, right? Because it just turns out that quality takes time. You want quality software with fewer bugs and it's more secure, that just takes time. Period. End of statement. So you have to sacrifice release schedules, right? I've talked about this before. You sacrifice the release schedule for the quality. There's no way around that trade-off. Ways don't exist. Are there inefficiencies in both, and can you make them better? Always. But it's still, at the end of the day, a one-to-one trade-off. Right? You want to get your software out quicker? It's going to be garbage. Right? It's going to be more garbage. Right? If you're willing to get it out slower, you can make it way better, and that lowers the maintenance cost on the software, right? And makes your customers happier because you're not releasing broken garbage all the time. Just the way it is. And it's interesting because nobody understands the scaling problems. It's just I watch Tech Ingredients. It's a great YouTube channel. You should watch Tech Ingredients. It's wonderful. I have a lot of fun with them. They do real science. They actually test things in the real world, right? Unlike the software industry, which gave up on testing about 10 years ago, hasn't done decent testing since, except when I consult and basically yell at them until they acquiesce. And they did this, we bought a jet engine, can we boost it? And it was like right from the go. They go, well, there's this principle, and you do this thing with airflow. And we thought, well, that's weird because it works on bursts, but it doesn't work in continuous applications. And I was like, why would you expect it to do both? And they did. I found that strange. I was like, what? Almost nothing. Almost nothing works that way in the real world. Actually, right? Like things that work in burst conditions rarely work in continuous run conditions. That's true in software, even. It's true everywhere. So I was shocked when he said it. I'm like, what? So now I'm like really hooked on the video. I'm like, ooh, are they right? And of course they're not. It didn't work. And it was great. They showed their failure and they validated their failure, which is even better. We're going to test this again just to show you that our numbers aren't wrong and that our theory is excellent. That's what I want to see. I don't want to hear stories of people whose theories were right. That's boring, right? I want to hear stories of people who are wrong, because then I can go through and find out why they're wrong. Like I said, their base assumption was, to me, bizarre. I actually told them that in the comments too. I think nothing works that way. Nothing. And so like that's a scaling problem across time, right? You don't understand. Well, you change time intervals, change from discrete time, from pulsed system to a continuous system. That's a change in scale, right? And so the principles involved are completely different automatically. Now, sometimes that's not a factor, but almost all of the time it's a factor, right? That's important. It's the same with software. So again, you can get people to write smaller pieces of code quicker. That's easy to do, right? And the advantage is smaller pieces of code are in some sense more maintainable as individual pieces of code. That's true. They're less maintainable in large systems though. And large, maybe medium-sized systems even, right? It doesn't take much software before small pieces of code become less maintainable than larger pieces of code. People don't know that. I get that. You got to have years in, or probably 15 or 20, before you kind of like are convinced of that, because it's not intuitive to us. I totally understand that. And these guys I respect. I've been watching their channel for years. They're fantastic. And they just made a basic mistake that I was like, what? How could you ever think that? You guys are really smart. Why did you make this mistake? Because it's not intuitive. It's not intuitive to us for whatever reason. And it's the same in software. It's not intuitive why making individual developers faster wouldn't get the product out faster. But it doesn't. It just doesn't. It's not intuitive why making smaller code blocks that are more maintainable at the code block level is actually less maintainable at the software level. But that's the problem of scale. As you scale things up, the physics change, the dynamics change, the rules change, the way the system operates changes. And that's impossible for most people to see from down below. You just have to have the experience in, and you go, oh, okay, this is totally different than what I thought. It's totally different from my expectations. Right, because scale matters. And with containers, you can always make the argument that containers are more efficient or whatever, but actually they're a horrible idea for large software projects. Horrible. And it may seem like, oh, okay, it makes sense in a microservices environment for deployment purposes. It does not. It actually does not. All you've done is you've moved a bunch of management and integration problems out of the software's engineers' purview, out of their scope, out of their scale, and into the DevOps space, right? And now the DevOps engineers make $250,000 a year, and you're making 80. I don't know, man. And now there's DevOps engineers everywhere. Most of them are terrible, by the way, but whatever. They are fixing the integration problems that you should never have created, because you should be a good enough software engineer to not have done that mistake. But because, and it's funny, Dave's Garage brought this up. Dave knows what he's doing. I got my disagreements with the guy, but he's pretty spot on. He's pretty okay. I'm not entranced with him or anything. I'm like, he's making a lot of mistakes here, but whatever. He's a good dude. The mistake is in in when you scale up works on my machine, which he went over. Containers is works on my machine, spread out everywhere. Like, it's funny that he said it. I said it in my last video. That's what it is. There's a meme about it because that's what it is. When you do that, you are making your developer worse. They never have to cooperate with anybody else. They can just make it work on their machine and go. And the microservices architecture and design methodology encourages this bad behavior. It's bad behavior. You should have your team together cooperating to have a consistent development environment and a consistent platform that they all agree on, so that when you go to release, it all just kind of works. And then, and I've worked in shops like this, you don't need any DevOps engineers at all, even in the cloud. At all. You might need one guy who kind of knows cloud stuff, whatever. That's how we used to do it, believe it or not. Wasn't that long ago, but I mean, by now it was long ago, but it wasn't like, oh my God, it was the 80s. No, it's not even close. I was doing cloud work before cloud was a thing in the late 90s and the early 2000s. And we set up huge clusters. I even set up a few Beowulf clusters in my private lab. But we set up huge clusters. And they were even clusters with different operating systems running every version of Unix known to man, pretty much, and Windows, right? And in one case, NetWare, right? And something else too. I can't remember. So big development environment with multi-platform compile and test modes in 2 different companies. Multi-platform compile and test modes. One interface, every developer's desk, auto setup for the compilers. C compilers, because that's the way you write code correctly. If you can't write in C, I understand that. Maybe you're not a good engineer either because you can't write in C. That's possible. You should consider that, right? If you can't do your own memory management, maybe that's going to bite you, because maybe the computer can never do proper memory management. Certainly true. And people love this idea of containers and, oh, they're great. Containers, that's Java. Old Java runs in a container. It's a containerized language. That's what Tomcat is. It's a container management system. It says that in the documentation, or it used to. It says that in the documentation. This is not new technology. It's very old technology. Java's a nightmare, partly because of the containers. All you've done is change the container interface, updated a couple of the things because finally, everybody caught up with Sun from the 90s when they invented the container technology to take advantage of their large multi-core CPUs for their customers. That technology's been upgraded and caught up with the Sun systems. Sun's now gone pretty much. That's all that's happened. This isn't new technology, and it's not being used well because people don't understand what you use it for. And, Dave kind of went over some of it, but really at the architectural level, it matters a lot if you're using containers or VMs. And the thing that you don't understand is that the cloud companies know exactly what they're doing. You want to run containers, you're going to pay a lot more money to run the same code than you would if you just didn't run it on containers. Oops. And it's not a little bit more money. It's a lot more money. They know how to make money. They know how to take advantage of bad development practices, right? So they're not stupid. How do I know this? Go look at AWS's annual reports. What division of Amazon makes all the money? It's AWS. They make the bulk of their money. They don't make their money selling products and doing storefronts and whatever else you think they do. They make all their money on AWS. AWS saved that company from bankruptcy. If you look at the history of how they made their money and which divisions were profitable, it's clear to see. Now, I'm not saying anything bad about AWS. I use AWS, whatever. It's fine. I like AWS. But also, if you're not careful, you spend a lot more money. It's 5 times more money to run in the cloud than it is to run it on your own. And the funny part is now we've got more DevOps engineers than ever, and people are running in the cloud. It's like, dude, if you've got that many DevOps engineers, you should actually build your own cloud. It will be 3 to 5 times cheaper, maybe more. And you could have just as redundant a technology. You got to remember, AWS, every component in AWS, with maybe some minor exceptions, is open source. They didn't write a line of that code. Now, they've written interfaces on top of the hard code, whatever. If you need interfaces, that's great. But you don't need interfaces if it's your internal cloud. So you could run those same open source software projects on your own personal cloud, even if you just leased machines from some other provider. You'd save yourself a ton of money. And you'd be just as redundant, if not more redundant, because there's things that AWS doesn't do correctly or doesn't do as well in terms of redundancy or as quickly. All that's available to you. But nobody knows this, even though this is trivial. Like from my perspective, it's from a systems engineering perspective, it's trivial problems to solve to build your own cloud. I've done it many times. Like I said, back in the day, like all the tools in AWS, I wrote those by myself, usually in under a week. There's nothing difficult about them. Were they fancy? Did they have nice user interfaces? No, I don't write nice user interfaces. It's not what I do. I don't need to. It's back-end stuff. Like, if you're going to sell to a bunch of clients, sure, you need a nice user interface. Don't hire me. I'm not going to do that. I'll do your back end. So hire somebody else to do the front end. But like, I was never in that situation. My situation was always get this running for the one development team and give them documentation. Easy peasy lemon squeezy. And people would call me in for, it's a year-long project. I do it in like a month. They'd be like, what the hell? I'm like, I've done this before. It's not that hard. There's nothing difficult about it, right? There's basic principles. You apply them, you're done. It's really not difficult to get all the cloud tools up and running. So the scaling issues matter, and how you implement scale matters, and how you design your software actually matters. What tools you use matters a lot less, except if you're using tools for a bad purpose, that makes a big difference. Now, I'm not saying that you can't get bang for your buck out of containers in a medium or large size project with the right design. You certainly can, but you've got to actually do the work, and that work is not easy. And most people probably don't know how to do that. And I'm betting almost zero of them are software engineers, because software engineers don't know that stuff. They shouldn't know that stuff. Shouldn't have to know that stuff, right? There's a big advantage to knowing what you know better and having somebody else know the other pieces better, right? I mean, cooperation is good. It makes us all better. And you're not getting around that problem. That's why DevOps engineers make $200,000 an hour or $250 a year or whatever it is. People make crazy money in DevOps right now. Crazy. They're charging tons of cash to do systems work that's actually quite trivial in most cases, and good for them, right? And software engineers, they don't make any money anymore, relatively speaking. There's a few exceptions, but my goodness, it's easy to make a lot of money in DevOps, especially if you have any experience at all. So, good for them. Good for them. But you didn't get around the specialization problem. You just moved it. You didn't make it so that all software engineers could just do the thing that they want to do and push out software by themselves. You had to hire a bunch of DevOps engineers and a bunch of security engineers just to get things back up and running. And you moved where you spent your money, but it's not any cheaper. And then you're paying your cloud providers 3 to 5 times more money than you need to for infrastructure, when you could run that infrastructure yourself, especially if you're spending all that money on DevOps anyway. Because all they're doing is layering tools on top of tools on top of tools to do something that, quite honestly, you would just write a script in Python to do. And you'd have one tool. It would be custom for your system, and it would work better than anything you could gin up using 12,000 tools on top of AWS. I'm just saying. So scale matters. How you do this matters. Architecture design matters a lot. And trying to get the software developers quicker by making each individual developer faster is a bad idea. And Agile encourages all these bad behaviors. It doesn't specify them, right? I understand it's not, quote, Agile's fault, but also it does encourage it inadvertently, and people are taking advantage of that. And there's no substitute for good planning, good design, and good management. You can't replace it with Agile or some other methodology, or extreme programming, or whatever. So that's just, a niggly thing of mine. This is why software sucks. This is why we have bugs. This is why none of my software on my phone works reliably anymore. And every other website I go to has a broken freaking form somewhere, and things are so inconsistent that you refresh a page and suddenly it works. Like, that's nuts. There's no reason for bugs like that. The one thing computers are supposed to do is be consistent and reliable, and you can write self-healing systems pretty easily, and we seem to have lost that ability. And it's a shame. It's a crying shame.